Thank you so much, Beatriz, for caring for all the organization, together with Effie, and that's Gerard in the background. You will see him at some stage. So let's start this webinar, this My Sustainable Forest Insight Series #1. And let me introduce myself. My name is Julia Yagüe, and I'm the project manager, My Sustainable Forest Horizon 2020 project manager. And first of all, let me thank you all, the presenters, all the attendees. We know that we have something like 90 people registered, so let's see who finally joins us. Whoever comes is welcome. Now, I wanted to mention for the general audience that this webinar was going to take place presentially in Lithuania. But because of the COVID situation, we had to change it into this webinar format, which in any case, we are sorry that we cannot be present in Lithuania. We know that we have many attendees from there, so thank you for that and for the interest. But on the other hand, the benefit is that more people from all over the world can benefit and attend. So having said that, I'll try to pass. So I will kindly ask you to mute your microphones to avoid interferences. And please send your questions and answers, whatever you might like to inquire throughout the webinar, through the chat tool. And also I would like to advance already that we will have a second webinar, perhaps more technical, on the 21st or 22nd of September. We will circulate this notification to all of you who have registered for this webinar. And how are we going to handle these 90 minutes that we'll be together, an hour and a half? Okay, in 4 blocks, 4 information blocks, basically, in which we are going to present you part of the results of the work done during the project period. Okay, still we have some 4 more months to go, but in the past, basically 30 months, since the end of year 2017, we have been producing a good number of information products, remote sensing information products, and we want to present you in 4 blocks, depending on the baseline data that is used. So these 4 blocks will be one focused on LIDAR, we'll start in a minute. Another one based on satellite data. The third one will be the products based on sonic data, non-invasive methods to know about the wood quality. And the fourth baseline data type will be statistical data. So this is more or less how it will be structured. All in all, My Sustainable Forest has developed 21 products from this data I mentioned. However, I don't know why. Okay, yes. Okay, these 21 products based on remotely sensed data, all the specifications are to be found in the website. And also there in the website, you can request whichever product is suitable for your silviculture procedures and that can support you. Today we will present to you some of these products, just a few, not the 21, of course, and you have all the specifications over there in the website. But then you will see how we have tested them throughout 6 different countries throughout Europe. So all our partners are present here today, and you will hear from them the work carried out in 16 different areas of interest, 16 sites, and particularly the challenges that our users engaged in the project have to face in their sustainable managerial tasks in the different forests with different characteristics. So all this, in short, is that in the website you have all the technical specifications of the 21 products and also the request form. The request form leads us to the platform. The platform is the means that we have developed to interact with whoever requests a product. There, each user enrolls in the platform through a secure registration basis. So each user is unique and access the data safely. Also, in the case that we need to exchange any field data or any proprietary data sets. So, and basically there you see the request form and the area and some of the products and how you can visualize the outputs, the data, and the platform allows also processing, but basically for whoever is the end user, you can visualize it. You can, in a GIS appearance and facilities, and also the products, the databases and the geodatabases can be downloaded. They keep all the standards. Here you have a sample. For instance, on the right-hand side, you see the products requested by this end user, and each one of the products is totally metadated, right, on OGC and Inspire standards. So you can download it if you want to use it on another GIS setup. And having said this, basically, this is all what I wanted to let you know. These are some views of the products that we will show you in a minute. And then I don't want to take up more time, and I want to pass the floor and the word to the next speakers. First of all, to Margarida Mendes from Portugal, from Raiz. And she will present to you some of the challenges Raiz, which is the laboratory of the Navigator company in Portugal, has to face. Next, Íñigo Lizarralde will present some of the technologies used for that challenge using LIDAR. And finally, Alfredas Galaunde from our colleagues in Lithuania will also refer to these products and how the Forest Owners Association of Lithuania has made use of it. So please, the floor is yours, Margarida.
Yeah, Margarida, please switch on your mic, camera, and you have now control over my presentation.
Good morning. Okay. Raiz is a forest and paper research institute. We are part of the Navigator company, a pulp and paper industrial. The challenge that we launched in this project was to develop products and service to support the need of data of high quality and quantity to improve the sustainable forest management in Portugal. Oh, sorry, I need to go back. Okay, sorry. The main problems that Portuguese forests face are related to the territory planning or ordinance and climate change. 39% of the territory are covered by forests. We estimate that 75% of these areas are abandoned or have no signals of management or sustainable management. Especially in the north and central regions, the dimensions of the forest property, the management units, are small or very small, what has hampered the implementation of a more active management. Also, the climate changes increase the occurrence of pests and disease and large fires. In the silvicultural workflow, there are specific moments where the quantity and the quality of the information with spatial and temporal resolution based on Earth observation or LIDAR could help the forest managers to be more efficient by focus their actions in areas problem and reduce the effort and costs of forest management. These moments are the site characterization, the continuous monitoring, and after the harvesting, and ensuring the continuity of the sustainable forest management. In the MySustainableForest project, we focus the work in two main problems: forest inventory and pest monitoring, with very interesting results for the pilot cases. But to apply the results for big regions or national level, we need to improve the collect of field data, the ground truth, to improve the algorithms and to validate the results in different environments. But we are very comfortable with the results, and we think this information will help forest managers in Portugal to be more efficient. Thank you very much for your attention, and I'm available for any question.
Thank you, Margarita. Okay, Inigo, now you should have control over one second. The presentation. Inigo from Fora. Perfect. Okay, one second. We have a problem with the sound.
Okay.
Okay, perfect. Yeah.
Yeah. Okay. So thank you very much. I'm Inigo Lizarralde from Fora. We are the responsibles for the LIDAR products, and as Margarita just said, we have developed different LIDAR products that users like Raíz needed. So I'm trying to go on.
Should be okay.
Okay, now, so the LIDAR solutions we develop, of course, they're based on LIDAR, that is stands for light and detection and ranging. So it's a technology with several forest-related advantages. Basically, for those of you who don't know about a LIDAR, basically it's what it's called airborne LIDAR. It's a sensor, a light laser sensor that it's airborne in a plane or in a drone, so it sends information to the field. This information is transformed in what's called LIDAR point clouds, and the use of LIDAR technology is very useful for forestry because this point cloud we have from the information, or from the LIDAR information, has a very good relationship with the vertical structure of forests. That means we can have a good idea of the vertical structure of forests through the LIDAR point, especially heights and canopy cover, but also all the variables derived from every point of this point cloud of LIDAR gives an idea of different variables. So all those variables can be very precisely estimated with LIDAR information, with LIDAR models. So with that, it's how we address the needs of their end users, and for instance, the needs that Raif just showed in terms of high quality data for sustainable forest management were addressed with this information. More specifically, I'm going to talk about this product from MySustainableForest project. It's especially the service 3 product 1 service, that it's the stand volume in cubic meters per hectare, above ground biomass tons per hectare, and CO2 stock and tons per hectare. In this case, for Raif, as you've seen in these results, in these maps, we're showing the 3 products. We obtain LIDAR information from both planes and drones. So some of the areas were flown by with planes, and other with drones. So it's a good example of how different sources of LIDAR information can be used. We could use ad hoc flights for the area, but we can also use for other uses. If there's some LIDAR flight already available, we can use it. So that's a good example. So using this LIDAR from both planes and drones in this case, plus field data that came from Raif, as Margarita said, we developed these LIDAR models that are statistically very robust. But it's not only the importance of being statistically robust, but it has these operational advantages. And as Margarita just said, it's a good advantage to as a business solution, because we're talking about industry, and they're comfortable and happy with these results. So I mean, I think that's a good point for the models. More specifically, I'm gonna just focus on stand volume from out of the 3 sub-products of this S3P1 service product. I'm gonna focus just on stand volume because, as you all know, it's one of the basic variables needed in forest inventory. It's like a very common variable, and we are focusing into sites. On one hand, for the harvesting, because as we saw with Raif, they need to have very accurate volume estimation. For the industry supply, they need to know for their supply what's the volume they have. In this case, accuracy of the model, of the LIDAR model we obtain, it's just directly transformed to money. For them, it's very important to, I mean, a percentage of better percentage of accuracy in the model. It transfers directly into money for the industry. So it's very, very important. But on the other hand, not only for industries and for harvesting, but just for forest management. And here I link with next speaker with our colleagues from Lithuania for volume is one of, as I said, one of the basic variables needed in forest inventory. So for forest management, inventory needs for owners or forest managers, it's very, very, very important. In this case, to be able to have good accuracy in volume, in this case, using LIDAR, it gives really information. It addresses the needs of FOAL in terms of having more precise and more frequent inventories, because that technology allows to have good information of volume, but also allows to have when new flights are available or other flights, ad hoc flights are done, we can address very accurate information of volume, but also we can help addressing the needs of FOAL in terms of better frequency of forest inventories. So I guess with that, I just give the floor to Alfredas, who will just continue this flow of information through to the point of the needs of FOAL. Thank you.
Okay, Alfredas, now you should be able to switch on your camera, mic, and control the presentation. Thank you.
Alfredas Galona from Lithuanian Forest Owners Association, and we are one of the partners in this project. So as continuing what Inigo was talking, so here's an example of one area of interest in Lithuania, close to Kaunas, the Drought Forest Tract. And you can see in this example that having LIDAR point clouds, you can get the volume we get from that model, and combining also the satellite imagery, Sentinel-2, combining with 3 species, we can, using the local models, we can get some forest inventory products. For example, in this case, which is shown in this slide, is volume of timber. So also these products, especially in LIDAR, you can use, you can improve stand delineation, forest infrastructure objects, and of course this volume of timber can be as a part of forest state cadastre, to use in forest state cadastre. So what I want to say, that Lithuania is a new country in the region, is still not using airborne LIDAR data in their forest inventories, just small experiments. And as we understand, it is the cheapest option to get the highly accurate forest survey data. Also, the recent reforms in forest sector had essential impact on forest inventories, especially for private forests. And so to fill the gap of this is the only way. It's different remote sense data, which is possible to use. And the sustainability and efficiency of LIDAR data for Lithuanian forest inventory is proven long ago in 2008, as I mentioned. And now this project, MSF, just confirmed this message, suggesting some innovative approaches. So thank you for your attention.
Thank you, Alfredas. So now I will introduce the next block. Julia, you can do the following ones, so we change them, so it's okay. So on this block, more focus on forest vitality and consistent conservation, but especially on biotic and abiotic damages. We'll speak first Zenek Katoka from the University Forest Enterprise from the Czech Republic, then Angel Fernandez from GMV, and then Benjamin Chapelet from the Center of Forest Owners in France. So with this, I will please, Zenek, turn your mic and camera on, and in 1 second, I will give you access to the keyboard. I cannot see you yet, or hear you? Okay, yeah, now.
Well, thank you for introduction. Review slide, yeah. So University Forest Enterprise is an integral part of Menlo University in Brno. This forest enterprise is also used to teach students and also for research purposes. It's also a model object for practical foresters. That's why the forests at University Forest Enterprise are somewhat different. Mixed forests predominate here, especially spruce, beech forests, but there are also pines, oaks. And,
okay, sorry. Sorry, I'm not sure what's the problem. 1 second with the presentation. We need to. Well, you can see now your slide, right?
yeah.
Okay.
So mixed forests predominate here, especially spruce, beech forests, but there are also pines, oaks, and other tree species. The vertical structure and silvicultural procedures are also different here. In addition to H-class forests, we also have uneven forests known as Dauerwald, selection forests, coppice forests, and forest reserves. So we are currently witnessing a major crisis in forestry caused by global climate change, namely a long-lasting drought and the consequenting bark beetle outbreak. Drought is caused by poor water retention in the landscape and increased evaporation. Drought weakens trees and makes them more susceptible to bark beetle infestation. Common annual logging in the Czech Republic is between 15 and 18 million cubic meters, and in 2019 it increased to 32 million cubic meters. Due to the different composition of tree species and vertical structure at University Forest Enterprise, the bark beetle outbreak has long avoided University Forest Enterprise, but now we also have big problems. And the early detection of infested trees and prediction of infestation is key to forest protection, and remote sensing data are suitable tools. We use multispectral images from drones for detection at tree level, but at the level of entire forest enterprise, products based on the satellite data are more suitable and very operative tool. These products will be introduced to you by Angel.
Okay, thank you. Angel, please switch on your mic and camera, and now you should be able to control the screen. Can you speak, Angel? So, oh, you are muted.
Okay, now.
Okay. Okay.
So thank you, Zenek, and hello, everyone. So now I'm going to tell you how within MySustainableForest we are using satellite data to help fighting bark beetle pests and other similar problems. Our main input is Sentinel, multi-temporal Sentinel data. Using that main input, we make two different basic products, which are the forest mask and main forest types. Using these two products and the Sentinel images, we compute vegetation condition baseline using mainly these three variables, which are photosynthetic activity, leaf area index, and water content. Then we receive an alert, which I will explain later. And using that alert and all the information we had before, we compute the anomalies in vegetation condition, and we categorize these anomalies in different damage categories to obtain the biotic or abiotic damage product. So I will start presenting a little bit the two basic products, the forest mask and the main forest types. So, okay, the forest mask is simply a binary forest land classification, which is obtained using both supervised and unsupervised machine learning algorithms. We have two outputs, which are the binary forest mask that you can see in the image on the left, and the forest probability map that you can see on the right. We have achieved an accuracy of around 95%. We can make the product with Sentinel-2 data, then we have 10-meter spatial resolution, or with WorldView with 2 meters. I'm going to be centered only in the Sentinel products, which have a minimum mapping unit of 0.1 hectarea. So with this product, we pass to the second one, which is the main forest types classification, which is a supervised image classification of the main forest types present in an area. So a preliminary study of dominant species in the area is required to perform the classification. And then we use supervised machine learning to obtain our outputs, which are, again, the main forest types classification that you can see here, and also a probability map per species. You can see that the accuracy is also around 95%, and using Sentinel-2 data, we also have 10-meter spatial resolution and 0.1 hectarea of minimum mapping unit. Here you can see another example of the main forest types, and the interesting thing here is that we give all the validation metrics per species. So this is very interesting because you can see where are the main errors, or which species are causing the main problems. And well, the second output of this product are the probability maps. Here you can see how it works more or less. So on the image on the left, you can see the probabilities of having two species with very different distributions. So the alder, which is a riparian species, and the eucalyptus, which is distributed in plantations. So you can see that there is no mixed probabilities. In the image on the right, sorry, you can see the opposite. So you can see two species that share the same distribution. They are riparian species, the alder and the ash. So you can see a lot of pixels in white colors, which mean that those pixels have high probability of having both species. Okay, once we have these two basic products, we compute the vegetation condition baseline, and we receive the alerts. So how does it work? So it's very simple. Basically, it can vary sometimes, but we are using three main inputs to consider our vegetation condition baseline, which are the water content, the leaf area index, and the photosynthetic activity. Once we have computed this baseline, we receive an alert, which can come from different sources. So it can be, for example, a European or global drought observatory alert. We can use the typical season, the typical dry season for the drought, for example. It can be a user-defined alert or given by the media or others. And we are working mainly with two types of alerts, which are the drought and pest outbreaks. Once we have characterized this alert, we use the two basic products and the baseline of vegetation condition to see if in the alert period there's signs of vegetation stress. And that's the last step. So how do we compute that vegetation stress? So firstly, we compute the vegetation condition anomalies, and depending on the type of anomalies, we categorize them into different damage categories to obtain the final, in this case, biotic damage product for the bark beetle problem. So this would be the biotic damage product, which detects the occurrence of pest outbreaks. Here we are using, we are mixing different types of statistical methods and machine learning algorithms to obtain the anomalies that you can see in the right image. Is what we call forest vitality, because we are seeing at a specific time the vegetation condition and the anomaly of that vegetation condition. So we have that output, but also the final output, which is the biotic damage classification. So we classify the damage in minor damage, moderate, or severe, depending on the vegetation health loss. So this product uses also Sentinel-2 data as main input. The spatial resolution is also 10 meter, but the minimum mapping unit is a bit higher, a bit better. It's 0.01 hectare. Well, finally,
2 minutes maximum, Uncle.
Okay, it's just the last slide. So we also have the Drought Damage product, which is very similar to the biotic damage. We are using similar approaches, but the variables are a bit different, and also the parameters. And we also have the two outputs, the first one categorizing the level of damage, and the second one giving an estimate of anomaly of the vegetation condition. And that's all. So I'm going to give the floor to the next speaker, Benjamin Chapelet from CNPF.
Okay, thank you, Angel. Please, Benjamin, yeah, I can see you now. So, yes. Angel, if you want, you can remove your camera. Perfect. I'll give you 1 second. I'll give you access. Now you should be able to control the presentation.
Okay. Hi, everyone. I'm Benjamin Chapelet from the National Center for Forest Ownership in France. I prepared 3 slides, and before I start, I'll give you some key figures to introduce CNPF and the French forests. Yep, it works. The territory is covered by 30% of forests, which 75% are private, with 3.5 million of owners and more than 12 millions of hectares. CNPF is a public body contributing to the development of private forests through advisory and coordination activities and training and knowledge dissemination. With regional delegation and more than 450 employees, CNPF has a wide range of partners, like in R&D, professionals, education, and private forest unions. In MSF, CNPF is involved through 2 areas of interest, as you can see on the map. In the region, in the center region, with stands with Cecil oaks mainly, and in the southeast, in the Nouvelle-Aquitaine region, with maritime pines. Next slide, it works. So the next slide is coming. Yes. Okay. As we've just seen with Angel, MSF provides Service 4 with data on forest conditions like drought and biotic damages that partners are currently testing and validating in the field. Even though damages forests seem to be well identified and accurate, to determine the causes, it's always tricky as forest diebacks are complex and multifactorial, and damages can have several causes with abiotic and biotic interrelated. For example, my colleagues told me that one area that was identified as drought damaged, actually it was because of hailstorm, ice cube falling down last year. Another example, like storms cause windfall with a huge amount of dead wood, and then are boosting the development of pests and disease, yeah, like bark beetle. So if damaged forest can be monitored from satellite, it's very important to combine it with ground control to determine precisely the reasons of these damages. For example, CNPF is involved in the national network of forest health with few correspondent observers in every regional delegation, and they are trained in forest health issues. So these observers are the local reference for owners and managers who are wondering about any damage they can witness in their forests. So the last slide, here is a schema in the center to remind you the definition of risks and impacts as they occur when hazard, like a storm, a drought, or pests, meet a vulnerable stand, like a monospecific plantation or a non-adapted trees, with important socioeconomic risks. On one hand, vulnerability and hazards can be driven and worsened by global change. And on the other hand, forest management can help reinforce the resilience of the stands and also the socio-economic parameters. So in conclusion, I would say that Earth observation and georeference data are already applied in many parts for monitoring numerous parameters, and they can provide foresters with solutions for their management.
Okay, so thank you, Benjamin.
Thank you.
Julia will introduce the next slide, so the next block. So now, Benjamin, you can, yeah, turn off, that's good. Before I go to the next slide and leave Julia to introduce this next speaker, I just wanted to make a reminder to all attendees or participants that join a bit later that you can do questions. Please submit your questions through the chat, and then we will at the end we will have some time to answer them. So you can, it will help if you put to who is address. Okay, thank you very much. So Julia, now you can speak and introduce the next two speakers.
Okay, thank you, Beatriz. And here we have already on the screen our next speaker, Ivan Pilas from the Croatian Forest Research Institute. And he, together with Esther Merlo from a small and medium enterprise, scientific and technical, both of them will refer to the wood quality assessment products, the needs they need for to estimate the wood quality and how Madeira produces these products without invasive technologies. So the floor is yours, Ivan.
You should be able to control now. I don't think we can hear you, so I think you're still mute. Okay, try to speak now.
Okay.
Yeah, perfect. Thank you.
Hello, everyone. As Julia said, I'm Ivan Pilas from Croatian Forest Research Institute in Jastrebarsko, Croatia. We are a public research institute, mostly concerned with the research and also dissemination of the results to our forestry practice. I would like to present you today one special and very new product that is the wood quality product, and Esther will explain you technically more in detail, but I just wanted to in few words tell you why this product is important, very important for our forest management. Okay, so we in Croatian forestry, our dominant, not by the area, but our forestry is mostly concerned with the Quercus robur forests and Quercus robur management in lowland floodplain areas. Quercus robur, it is the percentage of this forest maybe not the biggest, it's maybe 10%, but economically it is the most economically viable forest research forest species in Croatia. What are the management objectives? In Croatia, we have about 250,000 of these lowland Quercus robur forests. They are situated mainly in nearby big rivers, Sava and Drava rivers. What are the main management objectives? Are the production of the high quality hardwood timber, potential for veneer production. So for veneer production, the very narrow yearly increment is preferable. I must say the economic prices, for example, of oaks, 1 cubic of oaks, it also depends of the diameter. So if the diameter of trunk is bigger, like more than 70 centimeters, the prices are in Croatia more than 550 euros per cubic meters. Also, the prices in the market, for example, in Germany and Austria, in the Central Europe, can reach above 2,000 euro per cubic meter. So it is very highly valuable hardwood wood, mostly used for massive furniture production. So what are the challenges? It is the very long rotation period, 140 and 150 years. So in the meantime, you can see that this period there could be a lot of changes, droughts, pest intensification, human man-made activities, and so the goal is actually to manage forest and to manage all of these impacts and stresses. Also, what is the second challenge is high water demands. So this is the lowland robur. It requires a lot of water. What are the conditions in Croatia? We have the sites with the shallow groundwater tables, groundwater supply, and this could be very, very sensitive in terms of the drought periods when the groundwater drops. You can see here in the MySustainableForest project, we had two scenarios of interest. So you can see the map of the continental part of the Croatia, and you can see the left part. This is near the Research Institute Jastrebarsko, near the capital of Zagreb. And the eastern part, Našice, Vinkovci, this is a very large forest complex, actually two forest complexes of oaks. So you can see also here on the first image, it's one gradient. So in the western part, we have quite a wet condition. So more than 1,000 millimeters of precipitation. On the other side, on the eastern side, we have precipitation below 700 millimeters per year. So if you can in parallel, for example, in the eastern part, precipitations are very, very similar. Like for example, in Pamplona, city of Pamplona in Spain, You can feel how Pamplona environment is quite dry, but we have a very good productive forest here because of the groundwater and soil water resources. So soil water, groundwater resources are very, very important. You can see here on the left one picture of Quercus robur stand. It is a stand about 140 years old. So the objective of management is to produce these very high quality trees at the end, which are suitable and available for veneer production. And also we think here that the wood density product, wood density map, could be very, very good. It is quite new. We obtained this year the first results, but it's quite potential, for example, for the selection of the good trees during this long period. So the main this could support our forest managers to select the trees or group to the trees which are potentially trees of the future. So I think I did this introduction. Thank you very much. I would like to Esther to continue and to explain more of detail into this wood product. Thank you very much.
Thank you, Ivan. Esther, now you should have control over the presentation. Please turn your, yeah, I can see you now.
Hello, everybody. Thank you, Ivan, for your presentation. Well, my name is Esther Merlo. I'm director in a Madera Plus technological company. In this company, we are experts in predicting good technological properties by indirect data. Today, I will talk about the basic good density.
I'll pass the slide for you.
It's
okay, now I have passed it.
Okay. I go to talk about the basic good density properties and the product developed to indirect prediction these properties by remote data. Basic good density is the dry matter content of wood per unit of volume, and basic good density influence product quality and industrial processing, and it's very relevant for planning harvesting operation. But basic good density is also related to the susceptibility of the forest mass to drought events. Very, very important in the case of Quercus robur in Croatia, for example. At the field level, this property could be estimated by sonic methods or by core extraction. We can very quickly and precision data with both methods. But good density in a tree, we know that the good density in a tree is related to the growing condition, photosynthetic activity, nutrient uptake, crown size, climate, and physiography. There's inputs like Angel say could be indirectly predicted by several satellite data and index. And in this case, we use a mathematical model that relate these several data with the real true data basic good density measure from sampling cores in different trees in this region. The good density ranking product is co-designed with the end user as to adjust it to the user-specific needs.
I can pass it for you.
Thank you. In the case of Croatia, we obtain data in 2 different regions. 100 individual trees were collected in the 26 plots in 2 sites. One site close to Zagreb, and another site situated in the east of Croatia. To generate good density estimation, the MySustainableForest platform will make use of additional multispectral and multitemporal satellite image, Sentinel-2 image, of the previous growing seasons, and with the resolution of 10 meters by pixel, as well as climatic and physiographic data obtained from open access maps and database. The model was validated using cross-validation leap-on-out, and a statistical index, means square error, of cross-validation were calculated in order to examine the model prediction to external dataset. This is the good density ranking product that predict the basic good density properties using mathematical model developed based in satellite climatic and physiographic data. And with this good density ranking, you can obtain good density properties at substand level. We can be periodically update also. We can take more efficient strategic business decision before clear cuts. You can complete the good characterization of your forest and improve the accuracy of forest mass susceptibility to climate change. Forest owners, association, and industry wishing to take more efficient strategic decision can directly benefit from MySustainableForest products. Thank you very much.
Thank you, Esther. So now we move into the next speaker. A second. Okay. So on the final block of MySustainableForest, we will introduce those challenges and products related to forestry accounting. So first, we have Eduardo Montero from the Forest Owners Association of Navarra in north of Spain. And then Elena Gorriz from the European Forest Institute of the Mediterranean and the Forest Science Center of Catalonia. She will also speak. So Eduardo, please put your mic and camera on, and now you should have access control over the presentation.
Good morning. Thank you all for your participation in the webinar. And also, Beatriz, thank you for the introduction. I will be really brief to keep the time schedule. First of all, an introduction. I'm Eduardo Montero from Forestna Surgaya. Forestna is the Forest Owner Association of Navarra, located in the north of Spain. It's a non-profit organization who support private and public owners on sustainable forest management practice. Our role in MySustainableForest project is to know and coordinate the needs of the final users in sustainable forest management that can be solved with the use of Earth observation tools. Our area of interest in the study is the Roncal Valley, with an extension of 4,000 hectares. In this valley, the economy based on resource of the forest is very important. And there is production of wood and biomass for pinus and birch, and as well as other non-wooded products such as mushrooms, fruit of the forest, and honey. There is also a great use of the forest area for livestock with sheep, horses, and cows. Next slide, please.
Yeah.
Okay, thank you. Our challenge is to know the contribution of our environmental capital to achieve the objectives of European Union Green Deal. As you know, the European Union Green Deal has 3 general action points: achieving climate neutrality by 2050, protecting Europe's natural capital for people and health, and financing the transition, leaving no one behind. The forest has a very important influence on the first 2 points. And with this directive, the Commission will support businesses and other stakeholders in developing standardized natural capital accounting practice. So our specific challenge presented to be solved in the project with the forest accounting solutions are now our contribution to general wellness, evaluate our results in an economic vision, report timely their evolution, and also predict the future conditions of this resource. And now I think it's enough. I give the floor to EFI speaker to tell us how they have solved our request, and thank you all for your attention.
Hello? Can you hear me, Beatriz?
Sorry, I was I was muted. You should have now. I just passed the presentation, but you should have access. Okay, now we can see you as well. Perfect.
Perfect. Thank you very much, and thank you to all the participants. And as Eduardo has explained, the issue of environmental accounting is gaining more and more importance, and now it's still a voluntary process mainly. So you know that all the countries are giving or analyzing with their statistical offices the contribution of their economies to the gross domestic product. No, these are the very well-known statistics about the economic, but this is not really showing how the natural capital flows and stocks are reflected, no, and evolving during this process. So that's why from the World Bank and the UN, there has been, since already some years ago, an evolution and the standards of environmental accounting, which is still nowadays voluntary, but the idea, especially with the Green Deal, is that this will be at some point mandatory for regions, countries, and even at some point some big companies. So that's the interest, especially of MySustainableForest, that given that the cost of implementing such information is usually quite expensive, thanks to Earth observation systems, we might find nicer or timely or more regular ways to produce this information. And what I'm going to present now is the economics accounts for forestry, which have been applied to the Roncal Valley, what Eduardo was just presenting, and is basically divided in the land use account, in the physical timber account, and the monetary timber account. And besides that, I should give you an idea that these accounts are even more extended, that I'm not going to present that because it has not been the purpose here in the project, but this environmental accounting can also include carbon sequestration, water recreation, so other values of the forest that contribute to the well-being of humans. Next slide, please. Yeah. And for example, here in the land use account, what we see is how the forest area is evolving over time. Whether areas that were before at some beginning and some initial period were forest and in the end period, whether they have expanded to new areas or even if the species have shifted. So, for example, our colleagues from GMV, Angel was presenting before the forest type maps. So we can see, for example, in some areas how the climate change is promoting some species or others. Or we are seeing whether some areas are deforested or afforested. So these are some of the information. So basically what the accounting is information is saying is how is a fixed picture if one fixed year, 2011 in our case, and in a final year, 2018 in our case, and then how the flows have been during this period. Next slide. Yes, and then what is interesting is that we can even go more detail thanks to the satellite information, and we can even distinguish how these flows have varied according to the different species. And what is also even more interesting is that we can map them. So this is a very interesting information from not only strategic decision making, but also from an operational point of view. So where are these flows located? In terms of physical timber account, our units here are cubic meters. So we are seeing which is the volume of timber that is actually in those forests. Indeed, here what we are, given that we have this economic perspective, we are differentiating between which is the wood that is available for wood supply and which is the wood that is not available for wood supply. In this case, what is not available is because technologically is not possible, or these are protected areas. When I say technologically not possible is because, for example, is in a very steep mountain or something similar that is not to extract that timber there. So here again, what we can see is how were the opening stocks, so at the beginning of one period, at the end of the period, and again how these flows have evolved during this accounting. And again, we can map them in where these flows have been located. I have to say that in MySustainableForest, this type of exercise, the physical timber count, was done exclusively for the Pinus sylvestris species, which is the species which has more market value in the area of the study of Roncal. And finally, the monetary timber account. Here is where our units are euros. And here you can see the, well, the final numbers are not possible to be seen, but you can see how was at the beginning, how was in the end, and maybe it's surprising for some of you that the initial year, the initial stock value is higher than the end. So in this case, it's not a problem of the technology, etc. It's just because in the area we can see that the average prices of the Scots pine have decreased, and this has some explanation. But so here, this service is combining both the Earth observation system and quite an amount of external information that is more related to the markets or how the growth is estimated for the species under study. And finally, we can again map where are the parcels with more value, less value for the market and for one specific year. So this is in brief what we have been doing for the forest accounting. Thank you.
Okay, thank you, Elena, for your presentation. So we have concluded the 4 blocks. We will express all our daily challenges in the forestry sector and some of the solutions. I would like to thank you all the speakers for keeping very well the time allocation. So now we can have 15 or 20 minutes of questions, and I see there are some of them. I will just like to share that during this project, it has been like very collaborative with the data producers from the main 4 data producers have been working very close between them, especially for some of LIDAR and satellite input data set for other derived products, but also with all the stakeholders that have helped to improve and validate the products. With this, I will pass the floor to Gerard Fernandez from EFI, will moderate the session. And I would just like to say that everyone that Gerard will say, like, he has some questions, so please take at that time, make yourself with the mic on and the camera, so the speakers can see you. So with this, this is all yours, now, Gerard. I pass on.
Okay, thank you, Beatriz. Well, as you know, we have been having some comments in our in our chat and in the questions and answers forum. First of all, I would like to say to all the participants that this webinar will be published in our website soon. We will also add it in our social media channels, because we have been asked this question. So don't worry, because for those who have been accessing the webinar later after the initial presentation, don't hesitate that you will be able to see it in a second time. And then I have noted down a couple of questions. I mean, we didn't have like so many. I think that everything has been clear apparently, but I will read some questions that we have been having. For example, there's one question addressed to GMV about the pest and drought damage. This is a question made by Lucy, and I read it. She says that about this pest and drought damage product, if it's based on vegetation indexes or change in reflectance only. The final spatial resolution of your product is 10 meters. Does it mean that you analyze only RGB and IR bands of Sentinel-2? What about the other bands that are in 20 meters resolution? Do you use them too?
Angel, please unmute yourself if you are there, or otherwise, I guess Julio might be able to answer.
Hello. Can you hear me?
Yes.
Yes.
Okay. So hi, and thank you for your question. So our product is based in changes in reflectance, but also in vegetation indices and other variables such as texture indices. So there is a whole feature engineering and feature selection process behind it. So while it's quite complex, we are not always using the same variables as input, but in summary, we are using not only reflectances, so also indices and other input variables. And answering to your second question, we are also using the 20-meter resolution bands, so the shortwave infrared bands. Yeah, we didn't want to lose that information, so we have tested different resampling methods to perform data fusion to 10 meters or just the simple split of the pixel in 4 to pass from 20 to 10 meters. And well, surprisingly, finally, that was what gave us the best result in terms of accuracy and of quality of the product. So so yeah, we are also using the 20-meter bands, but we maintained our 10-meter spatial resolution of the final product, because almost all our inputs are at 10-meter resolution, and well, we didn't want to lose that level of information. Then if you see the minimum mapping unit is 0.1 hectarea, so these are 10 pixels of 10 per 10 meters, because we consider that, so while doing the validation, we realized that it's not always easy to So we cannot be always sure that what we are classifying is always fine under that minimum mapping unit. So we validated with that minimum mapping unit. That's important too.
Okay, thank you, Angel.
You're welcome.
Thanks, Angel. We have another second question. This is addressed to Esther from Madera Plus. And this question is made by Vicente Gomez, that he says, what are the remote sensed parameters more correlated with wood density?
Okay, Esther, I think you need to put your mic. Yeah, we can see you now. Thank you.
There are try different models, and the most important parameters are we were use directly the bands, sentinel bands from bands 3 from 9 from June to August during the growing seasons. But also we are correlation with the different index and the VE and SABI and EBI. I don't know if it's okay answer or.
We can wait for the feedback of Vicente, because then there are like several people asking now. And then I will get back to you, Esther, if there's another question related to it. Then there's another question now for Elena from EFI. From Vicente as well. He says, in relation with ecosystem services, could you talk us about what is now the European situation with the payment for the ecosystem services that country provides to cities? Thank you very much.
Well, this is a very extensive question, and this is not really related with the forestry accounting. Actually, besides, some of the information can be linked to the payments for ecosystem services is a specific policy and economic instrument to compensate landowners for the provision of something that is beneficial for the society, in this case, the ecosystem services. What we can do through the forestry accounting is to actually take the values, but take into account one thing are the values, the other things are the prices. And precisely the difficulty and the novelty perhaps of these techniques is that we are trying to illustrate in a language that the policymakers and the economic decision makers can understand, the things that actually don't have a market value or is difficult to see it, no? So we, through monetary evaluation techniques, we can provide different values to carbon sequestration, water provision, biodiversity, etc. Whether the governments later on use these values to create some sort of taxes or economic incentives to companies to compensate their emissions, etc., etc., this is something that goes, let's say, beyond the forestry accounting. Perhaps in the future can be somehow interlinked. But let's say that what we are proposing now here, but we are not proposing, actually we are following the international standard guidelines, is to reflect the full value. Yeah, not necessarily the one that is, let's say, interchanged in a sort of theoretical market of ecosystem services. I don't know if this is clear enough.
I will give you the response later on, Elena. Now I've been receiving as well as some answers from the previous questions. For example, Esther, Vicente says that thank you very much. So it was clear your answer. And now Elena as well. So he appreciates your explanation. Also, this is another question for Angel. About the previous question from Lucy. She is asking if it's possible to get any further details about the algorithm. Is there any paper in the journal? I mean, if you can clarify if there's more information about this algorithm?
So yes, so well, the ATBD is internal, so it's as far as I know, it's confidential. It's information, confidential information. So, but Julia, I think, could give you more details about that. And regarding the papers, we are now working in a paper that we expect to publish in a remote sensing journal, explaining the algorithm of biotic damage. So I cannot give you an exact date, but we expect it to be published in some months.
Yeah,
So,
also,
Julia,
Angel, you have you have some of the kind of short paper for the previous conference from I believe it was last year. So there, I think some of them might be already on the MySustainable website. So I forward the person to look into the I think it's on the outputs, right, Gerard, for the project.
Yeah, so sure. Far. I mean, if you check in our website in MySustainableForest.com and you check in the sections of our publications, all the latest ones are there uploaded.
Yeah, so there you can find some information about the two basic products, about the forest mask and main forest types. These are the first version, so now it's not exactly as it's written in the paper, but it's mostly the same. So we have some changes, but the workflow is mostly the same.
Julia, let me your microphone. Okay, now you can talk.
If I may, I would like to explain a little bit further and clarify about this access to the algorithms. Now, MySustainableForest is a Horizon 2020 project, and it's not only for research, it's a close to market project. So we have been also analyzing the market share, and pricing our products. So that's why we are close to market, and one of the requirements with the Commission is that by the end of the project, we are able to commercialize these products. And for that, amongst all partners, we are establishing commercial agreements amongst us and service level of agreements for the products that are shared amongst some of us. So there are commercial projection, not only interest, but projection as well for the European Commission. So the Commission has fostered us, supported us, and that's great because otherwise we wouldn't have been able to test these algorithms in so many different environmental situations and locations throughout Europe. Having said that, most of the algorithms and the science behind these products that we presented to you today, they are published, and we are obliged to publish them. But there are certain step forwards and scientific and commercial and industrial enhancements of these algorithms that belong to the royalties of each one of the partners. So, and that's just a very small part of it. But as Angel mentioned before, most of the algorithms are published in Science, and you can find also the publications and the link to the publications in our website. So we want them to make them public as much as we can for it.
Thank you, Julia. Lucy replies saying that thanks for all for your answers. She's looking forward to reading these papers. So thank you for your answer. There are no further comments or any other input from our audience. I just wrote in the chat that after this presentation, if you have any further comments or questions, do not hesitate to contact us in our official email contact, that is info@mysustainableforest.com. And also you can check our website with all the latest news, publications, and also technical information from our service portfolio. I just added the URL in the chat, mysustainableforest.com. So that's it. Thank you so much for your questions and for all your comments. And yeah, I will leave the floor now for Beatriz. Sorry, Beatriz.
In fact, yeah.
Okay.
In fact, it will be Julia who closed the.
Okay, Julia.
Yeah. Okay. Well, thank you to all of you for coming and sharing this time with all the team from My Sustainable Forest project. Thank you to the attendants. Thank you to all project members for giving all the details. I just wanted to finalize with a little homework for everybody. From My Sustainable Forest, and because we are living and suffering this COVID situation, we wanted to know and learn how COVID-19 has affected the sustainable forest management activities. And for that, we have prepared a questionnaire that is online on our website. So we kindly ask you also to come into the website, and if you want, you can answer those questions, and it will be very helpful for everybody, and the results will be published. Having said that, we hope that with this short introduction, at least we bring into the forestry sector all these new technologies, these remote sensing technologies, which we think and we are sure that can do so much for the day in, day out activities in managing in a sustainable manner all those forests. So with that, thank you so much for your attendance, and you will be able to link again to the recording. Thank you.
Yeah. Yeah, thank you everyone. With this, we will close the webinar, and then you will hear from us very soon. Thank you. Bye-bye.